All right, let's talk about transformations, specifically writing the rule of a function after particular transformations. Now, the very first thing that we want to remember are those transformation rules. So if you're going to be shifting up or down, that's f of x plus k. So you're just adding k to the function f, or f of x minus h if you're shifting left to right. Here you're going to replace x in the function with your new input, x minus h. You have a reflection over the y-axis being f of negative x, a reflection over the x-axis being negative f of x, a vertical stretch or shrink being a times f of x, and a horizontal stretch or shrink being f of ax. Now remember, with these two types of transformations, it's always going to be the opposite of what you expect. So if you were to say shift left 3 units, you're really going to do f of x plus 3. If you were to do a horizontal shrink by 1/3, you're really going to do f of 3x. So for these two transformations, it's always going to be the opposite of what you think. But that's the very first thing that we need to establish, is the function rules or formulas, and then we'll see in the problems how to apply them. Okay, let's look at the very first example, which is actually one that we've done in class. It says, let the graph of g be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. So this is different because it's asking us, or it's different from what we've seen before, because it's asking us to do two different transformations at once. So let's just begin by writing the rules. If you're going to do a vertical stretch by a factor of 2, that's 2 times f of x. And if you're also doing a reflection in the x-axis, that's negative f of x. When you combine those two transformations, it's going to be negative 2 times f of x. Now for this rule, it's pretty simple. I'm just going to take the function, f of x, and multiply it by negative 2, which is just going to give us negative 2x squared, right? Not anything crazy. The second transformation is going to be a translation 3 units down. So for the second step, I'm doing f of x minus 3. And I'm using this function to represent my f of x. So that would just be negative 2x squared minus 3. And that's our final answer. G of x equals negative 2x squared minus 3. Okay. Moving on. Let the graph of g be a translation 3 units right and 2 units up, followed by a reflection in the y-axis of the graph of f of x equals x squared minus 5x. Again, we're being asked to do two different transformations at once. The rule for a translation 3 units right is f of x minus 3. The rule for a translation 2 units up is f of x plus 2. To combine those two into one step, I'm going to do f of x minus 3 plus 2. Now this looks complicated, but the important thing to understand is that anytime I see this notation, f of something, all I'm doing is taking my x values and replacing them by this new input. So in other words, what that means is this part here, I'm literally just rewriting x squared minus 5x, but instead of x, my new input is x minus 3, and I put that in parentheses, and then I just add 2 at the end. That's all that means. So we want to simplify this. We don't want to leave it like that. X minus 3 squared is equivalent to x minus 3 times x minus 3, which is equivalent to x squared minus 6x plus 9. And then we still have minus 5 times x minus 3 and plus 2. Distributing negative 5 into the parentheses, I would get negative 5x plus 15 plus 2 on the outside. Combining our like terms, we get negative 11x, we get 11 and 26. So that all was just step 1. Now for step 2, we want to do a reflection in the y-axis, which the rule for that is going to be f of negative x. Which means, again, rewrite this whole expression. I could literally just copy. Copy and, well, let me paste. Paste. Okay? And instead of x, I'm just going to replace it with my new input, which is negative x. And make sure to do that in parentheses. And then simplify where we can. So this is negative x times negative x is positive x squared. Negative 11 plus, or times, sorry, negative x is positive 11x. And then plus 26. So that is your function for g of x. Okay, let's do a couple more. The graph of g of x equals 9x squared is a vertical stretch by a factor of 9 of the graph of f of x equals x squared. Describe the graph of g as a horizontal shrink of the graph of x. Explain your reasoning. Well, if g of x equals 9x squared, we could talk about how this is outside the parentheses because there are no parentheses, so that is a vertical stretch by 9. But how could we have gotten there? We could have gotten there by doing 3x squared, because 3x squared is the same as 9x squared. And then because 3 is in the parentheses, we can think of this as a horizontal shrink by 1/3. Now, it is important to notice that when I graph these, I do get the same graph. 9x squared and 3x squared, right? The same graph. So I could think of it as a vertical stretch because my y values are being multiplied by 9, right? Or I could think of it as a vertical shrink because my x values are being divided by 3. Oh, I forgot to put a 1 in the numerator there. But both points are on the graph, and both are good ways to think about how this function x of x squared is being transformed. I could think of it as a vertical stretch or a vertical shrink, because if I was to shrink this from left to right, it would get skinnier, it would get narrower. But if I was to stretch it up and down, it would also get narrower. So both transformations produce the same graph, okay? All right, let's try another transformation problem. Let the graph of g be a vertical shrink by a factor of 1/2, followed by a translation 2 units up of the graph. Okay, so just one rule this time. I'm just doing 1/2 f of x as my first step. So that's just going to be 1/2 x squared. Second step is a translation 2 units up, so that's f of x plus 2. So this one is too easy. So it's just that. Okay, obviously we have to write it as g of x equals that, but you get the idea. Okay, hopefully the next one is harder. All right, the next problem says, let the graph of g be a translation 4 units left, followed by a horizontal shrink by a factor of 1/3 of the graph of fx. Still too easy, but we'll do it anyway. So f of x plus 4, since it's a translation left. So here I'm evaluating my function f of x for x plus 4, which means I'm writing this function exactly as I see it. And instead of x, I'm going to get rid of them. In this case, there's 2. And I'm going to replace it with x plus 4 in parentheses. Okay, so what that is going to be x plus 4 squared, which is x squared plus 8x plus 16. I don't have anything to distribute into this parentheses, so I could just write that as plus x plus 4, and now I can combine like terms to get this expression. Next step says a horizontal shrink by a factor of 1/3, so that's going to be f of 3x. Again, second step involves evaluating the function for a new input. So f of 3x means I'm replacing my x values with my new inputs. So 3x squared plus 9 times 3x plus 20. 3x squared is 9x squared. 9 times 3x is 27x, and then plus 20. So this, after setting it equal to g of x, represents the function after these given transformations. All right, come on, give me something challenging here. Go through these a little bit quicker. So we got a vertical stretch by a factor of 4 and a reflection in the x-axis. So I'm going to do this all in one. So that's negative 4 times f of x. So that's just negative 4x squared. Step 2 is a reflection in the x-axis, so that's negative f of x. So that's just negative 4x squared, which is 4x squared. Oh, I read that twice. Whoops. It should have been a translation 2 units up. Sorry. So f of x plus 2. So it's still negative and just has a plus 2 at the end. And we're supposed to call that g of x. All right. Then we have a vertical shrink by a factor of 1/3 and a reflection in the y-axis. So that is f 1/3 f of x, and that is f of negative x. So step 1, 1/3 f of negative x. So that's just going to give us 1/3 negative x squared, which is just 1/3 x squared. Then a translation 3 units right means we're doing f of x minus 3. So it's going to be 1/3 x minus 3 squared. And honestly, you can leave your answer like that. That's fine. You could also multiply it out, but you don't have to. Oh, I ran out of space. But it's 1/3 x minus 3 squared. All right, 31 and 32 look a little bit harder. Finally, that was getting a little bit boring. Okay, horizontal stretch by a factor of 2 and a translation 2 units up. So that is f of 1/2 x plus 2. Now, because there's a little bit more going on with this function, it might be a little bit harder. Let's see. So that's going to be f of 1/2 x plus 2. So that's 8 times 1/2 x squared minus 6 plus 2. All of that is f of 1/2 x. Okay, 1/2 x squared is going to be 8 times 1/4 x squared. Eight times a fourth is going to give you 1/2 x squared, and then I can combine these like terms, so minus 4, followed by a reflection in the y-axis, so that's negative f of x, or sorry, that is a reflection in the x-axis. It would be f of negative x. So then that's 1/2 negative x squared minus 4. Negative x squared is just positive x squared, so that's g of x. All right, 32. We're going to do a horizontal shrink by a factor of 1/2 and a translation 1 unit down. So that's going to be f of 2x minus 1. So that means I'm evaluating the function at 2x, so 2x plus 6 squared plus 3 minus 1. I might just leave it. I'm going to leave it like that. Obviously, I'm going to combine like terms, but I'm going to leave it as 2x plus 6 in the parentheses. And then minus 2 on the outside. And now I want to do a reflection of the x-axis, which is negative f of x. So that's just going to give us negative 2x plus 6 squared, because we can't distribute into the parentheses since the parentheses is being squared, and then plus 2. Okay? And that's your final answer. Okay, so that's your final answer for that. I think I'm going to leave it there. I hope that helps.